Hello, this is Patrick at 1CNC West, and I'm very excited today to be able to demonstrate a little bit of 1CNC XR7 as well as talk about the 1CNC Active Cut technology. So first of all, what is the 1CNC Active Cut technology? Well, it's actually something that's been around for quite some time within 1CNC. In fact, if you've ever performed a high-speed pocket operation similar to this, that's the direct result of 1CNC Active Cut technology. Now, 1CNC Active Cut technology is more than just high-speed machining. It has to do with efficient toolpath. It also has to do with prolonging the life of your tools as well as prolonging the life of your machine tool. Examples of this might be cutting down the vibration that a machine tool might set up or resonance that it might set up when it starts machining lots of little tiny arcs when it gets in corners, or maybe distributing the heat across your cutting tool in an even fashion to make sure that the tool lasts as long as possible. Those are all different examples of trying to prolong the life of a tool or prolong the life of your machine tool. So let's take a look at XR7 and let's take a look at some of the new active cut features that they've implemented. So first of all, here you can see all I've done is just performed a high-speed pocket operation on this part. Why don't we quickly take a look at the cycle time? I'm going to double click on the toolpath group and let's go into job sheet. And within job sheet, we'll view our PDF file, and I'm just going to scroll down. And you can see now that I've used a feed rate on this at 20 inches a minute, and our cycle time is 5 minutes 33 seconds. So I'd like you to remember that. Remember the 5 minutes 33 seconds. So let's jump out of the job sheets here. All right, and we're going to head right into the pocket operations. I'm just going to right click and go into edit operation. Notice now that there's a new feature within 1CNC XR7 called feed control. Now you're going to find this within all of the high-speed toolpaths, the traditional toolpaths, face milling, profiling, and lots of different areas within machining. All right, so let's take a look at what this does. I'm going to click here and we're going to activate this. And so what this does is this controls the feed rate. Now, more specifically, it controls the feed rate when the tool machines a sharp corner or a very small fillet. So here we have corner settings and we also have the arc settings. Now you can see now that this is all based upon distance. So here we're saying, okay, when the tool gets 25% of the tool diameter close to a corner, then let's slow the feed rate down 50%. Now you can say, wait a second, I really want this manual input. So if you could put in something like 100 thousandths, and that way when the tool gets close to 100 thousandths to the corner, it'll reduce the feed rate back down to 50%, and then it will up the feed rate to its normal feed rate as it leaves the corner. Okay, now I'm going to just put this back to percentage of tool. Let's talk about slow down on small arcs. Okay, so here we have percentage of tool again. And so it's saying, okay, slow down for all arcs that are 20% smaller than the diameter of the tool. I'm going to change this. I'm going to go to manual and I'm going to put in 0.5 for that. And what that means is that anytime the tool machines an arc that's less than a ½ inch, it's going to slow the feed rate down by 50%. So we're going to click OK to that. That looks good. All right, so you might be saying, all right, well, you slowed the feed rate down when it comes to corners and you slowed the feed rate down when it comes to machining small arcs, but that's going to do nothing but just increase my cycle time. Well, the active cut technology in this example is not about slowing the feed rates down for corners and small arc machining. The active cut technology in this example is all about speeding up the feed rates for straight line cuts and for cutting arcs that have larger radiuses. So what we can do now is for feed rate, you can typically up this 30 to 50%. In fact, you can go higher if you want to. But for example, if I up the feed rate by 30%, that's going to be another 6 inches per minute. So we could say 26 inches a minute now for the feed rate. And know for sure that the tool is going to slow down when it gets in the corners and the cutting the small arcs. You know, I'm going to go a little higher. I'm going to say 28 inches a minute on this. And so this is going to be applied to all straight line cuts and all cuts on arcs that are bigger than a ½ inch radius. All right, so let's click next and we're just going to push through this, hit finish. All right, so the toolpath's been finished now. Now let's go ahead and take a look at our cycle time now. So we're going to just double click up here and let's go to our job sheet and we're going to jump into our viewing the PDF file. We're going to scroll down and now you can see that our cycle time has dropped from 5 minutes 33 seconds to 3 minutes and 58 seconds. So we've reduced the cycle time, but at the same time, and this is what's more important, is at the same time when the machine is machining these little tiny arcs or when the machine is making a corner move, the toolpath feed rate's going to slow down. And what that's going to do is that's going to cut down on the vibration out there on the machine tool. The spindle, the machine tool is not going to want to vibrate because it's trying to machine those sharp corners or small little fillets really fast. So we've slowed the feed rate down there, but we've increased the feed rate for these straight line cuts and also for these arcs that have a bigger diameter. So at the end of the day, the net result is that you're going to have quicker cycle times, and you're also going to prolong the life of your tools as well as the life of the machine tool. In fact, why don't we post out some CNC code really quick before we end this video. So let's double click here and let's go to post. I'm just going to use the default post processor on this. And I'm just going to do a search for the letter F because I want to search for feed rate. So Control F on the keyboard. That's your find tool, and you can see we're going to be looking for the letter F, find next. So there's our 28 inches a minute, and as I hit the F3 key on the keyboard, you can see that one CNC is switching between 28 inches per minute to 14 inches a minute throughout the whole program. And it's going to decrease your cycle time and increase the life of the tools and your machine tool as well. Very, very nice. Hey, thank you very much for watching, and I look forward to seeing you in the next video.